Okay, page 217, example 3.18. Marry a 254 by 254, 254 by 254 by 107 kg per meter. Structural beam is required to support a point load. What if you like point load? Yeah, you need 54 kilonewtons. So calculate the maximum effective span of the steel beam. If I can calculate the maximum effective span, they're looking for L. Effective span PL, which is unknown, and then calculate the maximum effective span of the steel beam to be able to carry the point load and self weight of the beam. Use a bending stress of 148 MPa. So they've given us an H profile parallel flange 254 by 254 by 107. We need to go to the back of the book. Rachaka table 254 254 by 107. Rinyakanani table Rinyakanani IXX Rinyakanani H divided by 2. Let's look for that size. Get page mark. Page 300. So on page 300, we look for a size. Yes, 254 by 254 by 107. I want in number 3, no 254 by 254, 1, 2, 3. So we look for the IXX. What is our IXX? 175. It has an SI unit, so not plug up by 10 to the power negative 6 and then M4. M4. Okay, and then H divided by 2. What is our H? H, I give our beam by our H put our move. So what is our H there? Value is 266,7. So we don't want H, we want H divided by 2 again. So we divide here by 2. What do we get? 133,35 millimeters. So this is what you do. This is how you answer the question again. And then now write down your data. Your data, the size of the beam, the IXX that you got from the table, the H divided by 2, and now the bending stress. They gave us a bending stress of 148 MPa again. 148 MPa. So they did not tell us to ignore the self-weight. In fact, they told us to calculate the maximum effective span that will carry the self-weight of the beam. Again, here we need to calculate the self-weight of the beam. So let us start Aramin. Calculate self-weight of the beam. Self-weight of the beam, you take this number, this one that is in kilograms per meter, again, you multiply with the gravitational acceleration. So it's 107 kilograms per meter multiplied by 9,81 times 10 to the power negative 3. What is our answer? So after calculating the self-weight, we calculate the span. This is the formula. M divided by I is equal to F divided by Y. So we need M. So we're going to cross multiply. We'll have I multiplied by F there. This I is the IXX that we got there from the table. And then this F is the stress. We have a stress of 148 MPa. They gave it to us again. So our I, as you can see, the formula will multiply at 10 to the power 6 again. So here it is, and then Y is H divided by 2. This is the H divided by 2. The reason the proper H divided by 2 was for us to be able to substitute more for Y again. So Y are in 133,35. What do we get?
194.
194. 57. 21,8. This is in newtons. Let us divide. Our final answer needs to be in kilonewton per meter. This is not in kilonewton per meter. Divide a million. Let's divide like a million.
194.23.
Million is 0.6. 123. 123. So it's 194.23. So this is our M. 194.23 in kilonewton per meter. Okay, so now let us equate to maximum bending moment. So we have our bending moment, which we calculated here, is equal to WL squared over 8 plus WL over 4. The reason here we have a WL over 4 is because they said it's a point load again. They said we should calculate earlier point load. So we have a point load. So our bending moment maximum is this one. We substitute again. So it's 194, comma 23, and then is equal to W here is the self weight. It's the answer here, self weight of the beam. What is our self weight of the beam? 1,05. And then multiplied by L squared. We do not have the L. L is what we want again. And then all divided by 8. Plus the second W, they gave it to us. At 254 by 254 by 107 kilograms per meter, structural beam is required to support a point load. Again, this WL over 4 is for point load. So the W a point load again. The load for the point load, which is 54, and then L we do not have it, it is what we want again, and then all divided by 4. So what do we do here, Limo?
L is equal to.
Okay, so the formula to calculate is Bn is equal to WL squared over 8 plus Wn over 4. This Wn over 4 is for the point load, so we're going to substitute W for the point load, the load for point load, which is 54, they gave it to us. And then this W is for the self weight of the beam, which we calculated there, 1,05. And then the L is what we want, so it's unknown. Our bending moment maximum, we calculated it and we got 194,23. And then what you're going to do here is say 1,05 times L squared over 8 plus 54 times 1 times L, this is L, times the L all over 4. And then you take the bending moment maximum to this side. Since it's positive, if it jumps the equal sign, it's going to be negative, and then you equate all of this to 0, and then this is our A, this is our B, this is our C. Simplify first before you introduce the quadratic formula, and then you'll get L as positive and L as negative. You're going to take the positive one. So, who shall find?